If life had taken 10% longer, Voyager's unforeseen discoveries. Imagine if life on Earth had taken 10% longer to develop. Our entire timeline of existence would be thrown into disarray. Quite a while back, we said our farewells to Voyager 1, sending it on a mission of no return. A mission that would unlock new gateways to our understanding of the solar system. Like a tireless worker, Voyager 1 has continued to send back streams of data, uncovering awe-inspiring truths about our universe and guiding us into realms we never knew existed. Now, Voyager has taken its work to an unprecedented level. It dropped an interstellar revelation so monumental that scientists could hardly believe their eyes when they saw the data. This shocking discovery has the potential to rewrite cosmic history. What exactly did Voyager 1 uncover? And is it true that the spacecraft has indeed crossed into interstellar space? Join us on this enthralling cosmic journey as we delve into what happened. Interstellar space has never seen anything like Voyager 1. This engineering marvel ventured into depths of the universe that have astounded even the greatest minds. For over 45 years, Voyager 1 has delivered mind-blowing findings, offering revelations that astronomers never expected, at least not within the spacecraft's operational lifetime. But how wrong we were! Voyager 1 has continued to defy all odds, surpassing its expected lifespan like something out of a Shakespearean epic. The spacecraft has ventured into distances that have left the entire scientific community speechless. Billions of miles from its launch pad, Voyager 1 continues to astonish with its ability to redefine the very fundamentals of space exploration. Thanks to Voyager 1, scientists have been forced to abandon certain limiting beliefs and adopt new models when it comes to interstellar exploration. It's as if we are rewriting the textbooks from scratch. Voyager 1 has kept everyone mesmerized by its seemingly impossible ability to still transmit data back to Earth, despite being light years away with technology that is, by today's standards, outdated. But Voyager 1 doesn't care how this makes us feel. It continues to surprise us with its latest bone-chilling discovery. Revelation that has scientists buzzing with excitement since they decoded the message sent back to Earth. Voyager may first have given us the interstellar discovery of the decade, a discovery we didn't even have to lift a finger to find. It took the cover off our eyes with respect to our impression of these Goliath planets, remedying incorrect ideas and growing the focal point through which we view these far-off planets. On account of the journey across the immense gorge that had limited our understanding of these far-off monsters, it was gradually filled as our eyes became accustomed to the interesting new universes that we didn't know existed in Jupiter or Saturn. Researchers could not conceal their shock at the fact that these universes were strikingly more beautiful, dynamic, and lively than we might have imagined. Space experts nearly shouted in joy when the data provided by these space probes showed that these planets housed dynamic volcanoes and magnificent ice fields. It was as if researchers had been granted entry into a Disneyland filled with the most wonderful space discoveries they could imagine. Who could have envisioned that a spacecraft, which is only a rare Volkswagen Beetle, could step into strange territory and emerge with incomprehensible discoveries, the kind we haven't seen or heard before? Like a valiant hunter daring to venture into the thick of a dense forest, Voyager 2 did the unexpected by being the first shuttle to get so close to Uranus in 1986. It continued on this epic trail until it floated past Neptune in 1989. To this day, history books hold Voyager 2's name as the only spacecraft to have gone to such lengths in exploring these two ice giants. What historians find more amazing are the landmark discoveries these notable visits brought to life. We would have remained in the dark regarding our impression of these two far-off universes if Voyager 2 hadn't dared to travel that far, on a journey that has taken it over 14 billion miles from our planet. Voyager 1 could not have overcome everyone's assumptions all by itself. Early in its journey, it had to get help. We see this when its grand voyage began with a gravity assist from Venus, a move never attempted before by any spacecraft on its way to Mercury. The Voyager spacecraft's journey is filled with records of firsts, one after another. They kept setting records each passing day as they sailed through the captivating waves of interstellar space. As exciting as this story sounds, it was not an easy ride for the Voyagers. It seems simple now, but years ago, when the space probes were moving through the different phases of this journey, A tense atmosphere overshadowed them. We see evidence of this during their many attempts to get the essential boost to Mercury. Moreover, the first leg of their journey to Jupiter was far from smooth, as the journey took them a distance 10 times farther from Earth than Mercury. This legendary journey saw the probes navigate through the horrendous waves of the asteroid belt, a path that threatened to block them from their objective. However, the spacecraft hadn't come this far to be deterred, so they powered through until they crossed the elusive region and continued their brilliant exploration of the solar system. Although Voyager had scaled through the asteroid belt safely, its problems didn't end there. There were still plenty of challenges waiting for the craft along the way as it sailed through space. Researchers realized that Voyager was in a sharp corner, especially considering it only had 69 kilobytes of memory, which was equivalent to a fraction of a smartphone storage capacity. Therefore, the probe's computers had to rely on onboard systems to manage the complexities of their journey. It is fascinating to note that the data gathered by the probe's instruments had to be stored on tape recorders before being sent back to Earth by a modest 23-watt transmitter, which was as powerful as a refrigerator light. Since Voyager was equipped with 12-foot dish antennas, it could conveniently use radio communication, traveling at the speed of light, to send and receive messages. Nevertheless, we can't help but marvel at the strikingly vast distance from Earth, which posed a significant barrier to these space travelers' success. This is because the great distance made it difficult for the craft to stay connected to Earth. It turned out that signals from Voyager 2 took over 18 hours to reach the ground crew on Earth. This challenge was further exacerbated by the ever-rising interference from Earth's noise, including radios, TVs, and cell phones, which made it harder to hear faint whispers coming from a spacecraft. Even so, Voyager 1 and its twin have scaled through these hurdles imperiously every year. Since the Voyager began its journey through the interstellar voids of our universe, it has been mailing back groundbreaking findings to researchers, discoveries that have left astronomers in awe. These findings are beyond astonishing, as they are revising our understanding of the distant realms in our universe. The beliefs we held dear about our universe are being tossed into the bin as a new understanding of the cosmos is being formed, ordered just before our eyes. One of the features of this interesting interstellar excursion was recorded when the explorer wandered into the Oort cloud, which is a terrific divine social event of comet-like substances bound together by the sun's gravitational force, extending most of the way towards the closest star. This far-off domain is one of the strange areas that the explorer has actually thought about investigating, and it is gradually revealing the endless mysteries stowed away deep in this grandiose domain. Moreover, one spot where Explorer 1 appeared to have radiated brilliantly was interstellar space, where the solar wind phenomena give way to a more open frontier. Before the explorer could step into this captivating area, it had to go past the heliopause, which is the boundary between our solar system and interstellar space. The moment the explorer crossed this line, cosmologists jumped up in excitement, and the entire academic community began to dream about the unimaginable discoveries that might emerge from this historic event. The explorer's introduction to this unfamiliar region came with several unsettling questions. For example, the initial estimates of the heliopause distance, before the explorer probes reached it, were inconsistent. However, researchers expected it to be around 50 astronomical units, and as a result, the mission's funding was increased. Nevertheless, what astronomers found striking was that, as the spacecraft departed from this milestone, no typical signs of interstellar travel were detected. So, we can understand why scientists were baffled by this mysterious situation. They waited in vain for signs of this unusual event, yet none surfaced. One of the expected signs of this highly anticipated crossing into interstellar space was a sudden increase in cosmic rays, high-energy particles ejected from supernovae and other cataclysms at nearly the speed of light. However, we have been told that most low-energy cosmic rays are deflected by the massive magnetic field created by the heliosphere. This heliosphere is the universe's gift to our solar system, as it shields our inner solar system from most external threats. It's like a giant shield, ensuring the safety of everything within the inner solar system. Moreover, the Explorer ground team had their eyes locked on the spacecraft as they kept tabs on changes in the dominant magnetic field. The interstellar medium, which is composed of ionized gases and influenced by nearby stars, was expected to have a different magnetic field orientation compared to the heliosphere. Hence, scientists were alarmed when the explorer reported no signs of such changes, further puzzling researchers. At this juncture, it was clear that the space probe had wrapped itself in a thick shroud of mystery. The picture became less hazy when, on August 25, 2012, the explorer crossed the heliopause and sent back intriguing data to the ground team on Earth. The transmitted data confirmed the expected increase in plasma density. But the story wasn't entirely successful because there was no sign of a change in the surrounding magnetic field direction. Astronomers found it hard to come to terms with this fact, as it was unexpected. It had been assumed that a change in magnetic field direction would occur when transitioning from a region where the sun's magnetic field was dominant to a region influenced by other stars. It took a while for this stunning finding to sink in for scientists. If we walk back in time to November 2018, we would be greeted by an interesting reel of how Explorer 2 set out on a remarkable journey into the interstellar ocean. This one-of-a-kind venture generated buzz in the academic community and has remained on the lips of astronomers since then. We can't blame them for being fascinated by this unexpected event, which saw the spacecraft arrive at the heliopause, the boundary of our solar system, at 120 astronomical units from Earth. What's interesting is that this was the same distance its twin, Explorer 1, had reached 6 years prior. Astronomers were excited that Explorer 2 could replicate the same feat. However, what scientists still found puzzling was how Explorer 2 detected no changes in the magnetic fields, which contradicted what theoretical models had suggested. This strange occurrence added yet another layer of mystery to the spiritual pool that the space probe was swimming in. Astronomers were scratching their heads in search of an answer, but at every turn, they encountered a dead end. It seemed as though the dark clouds were destined to prevail over this matter forever. It was astonishing that the explorer's behavior went contrary to expectations. For example, predictions told us that the heliosphere, influenced by the sun's 11-year cycle, should have ebbed and flowed just like the solar wind. Scientists were surprised when existing models failed to explain discrepancies in Explorer's observations, particularly as the solar wind peaked upon Explorer 2's arrival, suggesting the heliopause might be farther than 120 astronomical units. Minor changes near the heliopause, influenced by the heliosphere, raised questions about the explorer's transition into the true interstellar magnetic field. Conflicting views emerged among scientists. Some believe the explorer remains within the heliosheath, while others think it has already crossed into interstellar space. Influenced by increased cosmic rays and plasma density, the Explorer's sturdy systems, running on decades-old technology with minimal software, continue to captivate as they approach Proxima Centauri, promising extraordinary discoveries if their mission extends to 2030.